Okay, so let's continue with sine, cosine, and tangent of 0 degrees and 90 degrees. For this, we're going to have to use our imagination. Can you imagine the ground and a wall next to the ground? If so, this will be easy. One more thing. Let's suppose that on the ground there's a laser pointer. And let's say it's oriented at some angle theta. And that laser pointer is shining a light on the wall. Beep, 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 beep. Well, this will make a triangle. We see that the opposite of the angle theta is this side, formed by the part of the wall between the laser light and the ground. The adjacent is this side, formed by the base of the laser pointer and the wall, and the hypotenuse is the length of the laser itself. Well, we don't want sine, cosine, and tangent of any old angle theta. We want sine, cosine, and tangent of 0. So let's imagine that the laser pointer is moving downward, so that this angle is descending towards 0. Well, if this laser pointer is moving downward, then the opposite, which used to be this length, is now this length, or even shorter as it moves down. Maybe this is the opposite, and when it descends even further, that'll shrink down to 0. So the opposite shrinks down to 0. The adjacent stays the same, however. So opposite goes to 0, adjacent is still what it was. What about this hypotenuse, though? So the hypotenuse used to be this thing. Now it's this thing. And as the angle declines even further towards 0, you see the hypotenuse and the adjacent end up being the same length. In other words, the hypotenuse approaches the adjacent as theta goes to 0. Well, let's see if this can help us. So sine of 0, I forgot to write SOHCAHTOA, our magical incantation. Sine of 0 is the opposite over the hypotenuse. But the opposite became 0 in the limit as the angle approaches 0. Okay? So it's 0 over the hypotenuse. Well, 0 over anything is 0. So that's 0. What about cosine? That's adjacent over hypotenuse. But in the limit, the hypotenuse and the adjacent become equal. The hypotenuse approaches the adjacent because as the laser pointer descends, this length becomes that. So we're essentially dividing something by itself, and that's 1. Okay, tangent, that's opposite over adjacent. The opposite becomes 0, the adjacent stays what it was. That's 0. Finally, good old 90 degrees. We want sine of 90, cosine of 90, and tangent of 90. We'll have to use our imagination for this one as well. But this time, we'll imagine a laser pointer affixed to the wall rather than the ground. Now the angle theta will still be the angle between the laser line and the ground. But we're still going to imagine this angle becoming smaller and smaller. So the laser pointer is going to approach the wall. You'll notice as the laser line approaches the wall, the angle at the top gets closer and closer to 0, but this angle theta at the bottom gets closer and closer to 90, right? If I draw another laser line like this top angle is very close to 0, and this bottom angle is very close to 90 degrees. So we have theta approaching 90 degrees. This is what will allow us to calculate sine, cosine, and tangent of 90. Okay, so if you imagine this angle theta, it has an opposite, an adjacent, and a hypotenuse. The opposite is this side here. The adjacent is the side determined by where the laser light hits the ground and this corner here. And the hypotenuse, as it was before, is the length of the laser line. Okay. So here it's the hypotenuse and the adjacent that are varying and the opposite that's staying the same. Now, if we imagine this laser moving closer and closer to the wall, then the adjacent is going to 0. And this laser line, the hypotenuse, will eventually just become the height of the wall, the opposite. So the hypotenuse is approaching the opposite. And that's all we need to determine the three trig functions of 90 degrees. So let's start with sine of 90. Opposite over hypotenuse. Well, the hypotenuse is approaching the opposite. So in the limit, they're equal. So anything over itself is 1. Therefore, sine of 90, that's 1. Cosine of 90. Adjacent over hypotenuse. Well, the adjacent is approaching 0. So 0 over any non-zero number, that's 0. Finally, tangent of 90. Oh boy. Tangent of 90 is TOA. Opposite over adjacent. Okay, remember the opposite is that fixed length, the height of the wall. But the adjacent is approaching 0. So we're dividing the opposite by 0 essentially. That's an uh-oh. That's undefined. Okay, so we'll just write undefined in our table. And that's it. We've completed the table. So if you want to know sine, cosine, and tangent of any one of these standard angles, 0, 30, 45, 60, or 90, just look at your table and you get an answer. But this might be a little hard to memorize, so I'll show you a little trick that'll help you do that. Well, math is all about patterns, so let me write a little pattern on the board. Let's see if you can follow along. So I'll write square root of 0 over 2, square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, and finally square root of 4 over 2. I think you can see the pattern here. It's square root of the numbers from 0 through 4 all over 2. Let's simplify these. So square root of 0, that's 0, because 0 squared is 0. So 0 over 2, well, that's just a big fat 0. Square root of 1, that's 1. Similar reason, because 1 squared is 1. Okay. So this is 1 over 2. And we can't simplify that any further. Square root of 2, well, we can't really simplify that at all. 2 is not a perfect square, nor does a perfect square go into it. Same with root 3 over 2. Let's just leave that alone as well. 4, however, that is a perfect square. It's 2 squared. So So this is the same as square root of 2 squared over 2. Of course, the square root and the square cancel out. And that just leaves us 2 over 2. And as we all know, that reduces to 1. Okay, so you see, we now have 5 numbers after we've reduced. These 5 numbers are 0, 1/2, root 2 over 2, root 3 over 2, and 1. And these 5 numbers appear in the first column going down. 0, 1/2, root 2 over 2, root 3 over 2, and 1. So if you can remember this pattern, you can remember sine of these 5 basic angles. Well, what about cosine? Cosine is actually the same pattern, but you read it bottom up. So it starts at 0, goes 1/2, root 2 over 2, root 3 over 2, and finally 1. Not that hard, is it? This is a good pattern to remember.